This is the second of a pair of videos that introduce regular expressions. In it, we'll go through some examples of applying regular expressions to achieve three things: finding, finding and replacing, and finding, capturing, and replacing text in a file. If you want to follow along on your own, you'll need two things. First, the example data file, which you can get at the link pasted in a comment pinned to this video. Second, you'll need gedit, which is a text editor that has a free version for all the major operating systems. I've also included a link to the gedit download page in the same pinned comment. If you download and install gedit and have trouble opening it, make sure you have Java installed on your computer, as that's a requirement. Other text editors like BBEdit for Mac and gedit for Linux should have similar functionality, and so they can be used instead if you prefer. But of course, some of the details will vary. We'll start by opening up the example data file, which I've called regexpractice.fa. This is a file that stores a set of hypothetical DNA sequences collected in a metagenomic study. In this FASTA file, each DNA sequence is represented by two lines. First, a line that stores the name or description of the sequence, which is sometimes referred to as a def line or definition line. According to FASTA format, these lines must each begin with the right pointing arrow or greater than symbol. The associated sequence data follow on the next line, and that repetitive name sequence pattern is repeated throughout the file. In this hypothetical dataset, each sequence represents a different type of microorganism that was part of a sample collected on a specific date and from a specific environment, both of which are included in the name of the sequence. The number of times each DNA sequence was sampled in the study is indicated by the number at the end of the name line. Although all of the DNA sequences are expected to consist of only A, T, G, and C, sometimes the sequencer will insert an N when it's not able to confidently make a base call. Let's start by using a regular expression to see if there are any sequences in this dataset that contain Ns. We'll first do a simple search for N in the file. You can select the Find option under the Search tab to open the search box and perform a simple search by entering N and hitting Find. Doing this, we see a problem. All the name lines have an N as part of the name of the sequencing platform used, Illumina MiSeq. We could search through the file one match at a time to look for sequences with Ns, but we can take advantage of regular expressions to do this in a much more efficient way. gedit supports Perl regular expressions, and since those are an extension of POSIX extended regular expressions, we have access to all of the wildcard characters on this slide that we looked at in the previous video that introduced regular expressions. For this search, we'll use the caret and square brackets as modifiers, and also the star and plus as quantifiers. In the search box, we'll enter caret, square bracket, ATGC, star, capital N, plus. Before we press Find to start the search, we need to make sure the box for regular expressions is selected. Otherwise, the expression will be interpreted literally and won't find what we're looking for. Let's take just a few seconds to think through exactly what this regular expression is doing. The caret forces the following character, or set of characters, in this case A, T, G, or C, to match at the beginning of the line. I've included the star modifier after this character set, which allows any number of these characters to occur, including 0. Next, I have a capital N, which is what we're looking for, followed by the plus quantifier. This plus quantifier requires that at least one N appear in the line. This expression gives us what we're looking for, by matching only lines that contain at least one N, but also requiring the lines start with either A, T, G, C, or N, eliminating the name lines that all start with a greater than symbol. One thing to keep in mind about regular expressions is that there are often a number of ways you can write a regular expression to achieve the same result. For example, we just used this regular expression, but replacing the ATGC inside the square brackets with another caret and the greater than symbol, and then removing the star after the square brackets would work equally well. In this case, because the caret is inside the square brackets, it negates the match. meaning this part of the expression will now match any line that doesn't start with the greater than sign. The n plus still requires that the line contains at least one n. Now that we've used regular expressions to find a specific pattern within text, extending that to replace text is straightforward. As I mentioned earlier, the last field in each of the name lines is the number of times that specific DNA sequence read occurred in the dataset, but that might not be readily apparent to someone not familiar with this dataset. To try to clarify, let's add underscore reads after each of the counts. We'll utilize the $sign modifier, which forces a match to occur at the end of a line. Since we don't want to add the underscore reads to the sequence lines, which we know should all end in either A, T, G, C, or N, we'll also use the square brackets and the caret inside them to match anything except these 5 characters at the end of a line. We'll specify that we want to replace all the matches with underscore reads, and then hit replace all to do the replacement. When we do, underscore reads is added at the end of each of the name lines. Some find and replace tasks are relatively simple, while others can be a bit more complicated. Regular expressions are unique in the power and flexibility they offer for dealing with some of the slightly more complicated scenarios. This includes the ability to find, capture, and replace text, and we'll look at an example of that now. Notice the first field in each of the name lines stores the date the sample was collected. However, the format of the dates isn't consistent. In some cases, it's year, month, day, and in some cases, month, day, year. What if we wanted to clean this up and standardize the format so that all the dates were formatted year, month, day? If you scroll through the file, you'll see that there are only 2 different dates represented, April 15th and May 30th. So one option would be to do a find and replace for each of these. Replace all of the 04-15-2019s with 2019-04-15, and then do a similar replacement for the May 30th date. However, what if you had 100 different dates? It would be really tedious to do each one individually. Instead, we can take advantage of the find, capture, and replace capability of regular expressions to do this all in one step. There are 2 new bits of notation to introduce here that are necessary for this. First, the parentheses. When you're using a regular expression to match a pattern within text, if you wrap a portion of the regular expression in parentheses, the portion of the text matching that part of the regular expression will be stored as a numbered variable that can be retrieved and used as a replacement. It's also possible to use multiple sets of parentheses within a single regular expression and store and retrieve the results of each. When matches are stored, they are assigned to a number, 1, 2, 3, and so on. There is some variation in the notation used to retrieve the stored items. JEdit uses $1, $2, etc., while other programs might replace the $sign with another character such as the backslash. For the changes we want to make to the dates, we'll take advantage of the fact that regardless of the specific date, the pattern we want to match and replace is 2 digits, dash, 2 digits, dash, 4 digits. We want to reorder this so the 4-digit part, the year, comes first. Because JEdit implements Perl regular expressions, we can use \d to match digits, and we'll follow these by the curly bracket quantifier to specify the number of digits we want to match in each case. So, the regular expression we'll use is \d curly bracket 2 dash \d curly bracket 2 dash \d curly bracket 4, and we'll wrap each of the sets of digits in parentheses, which will create 3 variables numbered 1 through 3 that store the corresponding matching text. Then, in the replace box, we can use the $sign notation to retrieve what's stored in those variables. We'll start with $3, which should contain the 4-digit year, then a dash, then $1, the month, another dash, and $2, the day. Hitting replace all reorders all of the dates that are in the month, day, year format to year, month, day, like we want. One final regular expression topic we'll cover deals with what is called greedy behavior. If I search for text matching the regular expression dot star colon, which will look for any characters any number of times and then a colon, there are actually several sets of text in the first line of the file that match this pattern. For example, it could select everything up to the first colon, everything up to the second colon, or everything up to the third colon. Technically, each of these matches the expression. If we actually try it, we see that the third option, everything up to the last colon, is what is actually matched. This is called greedy behavior. By default, when there is more than one valid match, the longest one will be selected. Adding a question mark after the quantifier in the regular expression turns off greedy behavior. And if we try with that, we get the shortest match. Don't get too caught up in trying to memorize all the different wildcard characters for the different flavors of regular expressions. There will be a subset you'll use more frequently than others, and you'll get comfortable with those as you use them. But it's always easy enough to do a quick search online to look up what you need for a given type of regular expression. More important is to develop some of these broader understandings about how regular expressions work and what types of scenarios they can be applied in. For a case like we just saw with formatting the dates in this example data file, taking advantage of regular expressions can sometimes go a long way toward reducing the time you might otherwise spend doing rather tedious tasks. In upcoming videos, we'll take a look at some command line commands that implement regular expressions.